All right, let's take a look at notes for day 5. We have section 1.4, polygons, and section 1.5, triangles. We're going to start off with section 1.4, polygons. So definition, polygon is a closed figure that is formed by connecting line segments endpoint to endpoint. So take a look below. You don't have to draw these if you don't want to, but the examples and the non-examples, take a look first at this thing. We see it's not a polygon because the endpoints don't connect. That thing isn't a polygon because it's only a line segment. You need at least 3 line segments to build a polygon. This shape, this oval, is not made up of line segments. And likewise, this shape has a part of it is made up of line segments, but not all of it. And then that thing isn't a closed figure, right? We've got this kind of crisscross thing going on. So polygons, you're probably familiar with a bunch of the names of polygons already, right? A 3-sided polygon is also known as a triangle. You might know the rest, or at least some of the rest. Maybe try and fill it in on your own, pushing pause. 4-sided shapes are called quadrilaterals, pentagons, hexagons, heptagons. And then we also have 8-sided shape is an octagon, 9 is a nonagon, decagon, undecagon, and dodecagon. So you will be responsible for the polygon names for sides 3 through 12. If you ever have a polygon where it has, let's say, more than 12 sides, you can call it an n-sided polygon, or more simply just an n-gon. For example, here we have a 13-sided polygon, and so we can call it an n-gon, or sorry, a 13-gon. Next, sketch yourself a pentagon. It is a pentagon even though the sides are not all the same. And I've labeled the corners A, B, C, D, E. Whenever you name a pentagon, or name a polygon, that is, you start in one place, and either moving clockwise or counterclockwise, you list the vertices in order. So for example, we could call this A, B, C, D, E. Or if you started at the top and went counterclockwise, you could call it B, A, E, D, C. You cannot call it B, A, C, D, E. The reason why is you're not moving in consecutive order. You're not moving in basically in order of the clock or counterclock. Some other vocab, we would call A, B, right? Those would be consecutive angles. Consecutive meaning one right after the other. The corners have a special name. They're called vertex, is the name of a corner. The plural of vertex is vertices. And so we would say, for example, B and C are consecutive vertices. Consecutive sides, for example, are just sides that share an endpoint. Some other definitions with polygons. We can have convex or concave polygons. A convex polygon is one in which no diagonal is outside of the polygon. And by a diagonal, I mean connecting endpoints across the diagonal. So this thing would be convex because none of the diagonals are outside. And here would be concave because if I connect those 2 vertices, that diagonal is outside of the polygon. One final definition for this section, we would say that polygons are congruent when all the corresponding sides and the corresponding angles are also congruent. Let me show you an example. Here we have 2 quadrilaterals, and because of those congruence markings, I know that all 4 pairs of sides are the same. And likewise, I see that all 4 pairs of angles are the same. So that means that quadrilateral CAMP is congruent to quadrilateral SITE. Moving on to section 1.5, we have a couple of definitions involving triangles. Right triangles have a right angle. They can only have one, they can't have more. Acute triangles have 3 acute angles in them, and obtuse triangles have at least one, or pardon, not at least, they have exactly one obtuse angle in them. Few other definitions: scalene, equilateral, and isosceles. Scalene triangles have no congruent sides. All 3 of the sides are different. Equilateral, all 3 of the sides are the same. They're all congruent. And isosceles triangles have at least 2 congruent sides. Final example, draw yourself an isosceles triangle. We just want to label some of the parts. The vertex angle is the angle that connects the 2 congruent sides. The base angles don't connect the 2 congruent sides. They connect to the base, which I guess if you look at this on its side would be kind of a nice isosceles triangle for us.